Here's a Hackaday story about evaluating Raspberry Pi as a programmable logic controller. That's from August 2020. So that story was that, and this is how I read it today. It's about industrial PLCs used in process plants or in industrial automation in general. They tend to communicate with analog current loops, which give it some immunity to the kind of electromagnetic interference noise that is around. So, for example, a temperature gauge will produce it will sink a current in a loop, and the number of milliamps of current is proportional to the temperature it's sensing, and then the sensor at the other end just needs to be measure the current going through a resistor by probably an ADC converter across. And the comment I just wanted to make was that if you go and look at this evaluation of the Raspberry Pi, they compared a Python-based control loop on a Raspberry Pi 3B against an automated, presumably that's from Automation Direct ADC shopping catalog programmable controllers, Click Series PLC, stackable micro brick PLC units. You don't need to go to see what it's about. So that's compared against an industrial unit. Which is that, I guess. And that's the Raspberry Pi with an interface hat board on it. So this is either a voltage minus 10 to 10 volts on a ground, presumably, and or a 4 to 20 milliamp current loop. And there's an article yesterday, or was that was also yesterday, how to do this in a form that will allow you. What is it he did? All it is a manual way of setting the current loop so that you can calibrate a sensor. And all he did was take the output of a PWM. He took a PWM output, smoothed it, and he shows you how to do that. And he used an Arduino Nano. So the hardware is pretty simple, but the problem with the software is it's just not fast enough to act like, I mean, this is some kind of open loop process controller. It needs to respond very quickly in order to maintain the temperature, I guess. But here's the crucial bit. The behavior of the two systems showed that while both did the task they were programmed for, the Pi was decidedly more erratic. And the problem is, basically, Linux is not a real-time operating system. But Linux was just, I always thought Linux was a stopgap for the Raspberry Pi. I thought the idea was to produce a decent operating system on it. And Linux is okay as a development environment or general purpose computing thing, but what you need is a system where only the only code that runs on the embedded controller is code that is actually doing the job of whatever that embedded controller is trying to do. If you think about what it is, it's a series of interrupt handlers connected to clocks and whatnot that are all intercommunicating via buffers that are just as big as necessary. And the whole thing ought to be, in principle, programmable and kind of verifiable in advance, so you know that it's within certain limits. It's not going to blow its buffers and lock up. That's the right way to program these things, not by installing a general purpose operating system on it and then making it into something that, the hacking that goes on is crazy.